Alright, what's going on YouTube? The world may look a little different than normal, but familiar to some who've been around for a bit. This is my test world, and you may have seen this when I demoed all the AI. Now, I'm not exactly going to work on AI demoing as of right now, and it has nothing to do really with the FPS series. This just is my test world for my FPS series, and so I thought I'd just load it up for this episode that I kind of wanted to show you guys. It didn't really fit in with any of my other series. It was just something I found how to do, and I didn't know if anyone really wanted to know how to do it. So I'm sure there are some people who want to know how to do this, and so I'm putting this video out here. Now, if you haven't paid attention well to the title, or you're just curious about exactly what this is, pretty much what I'm going to explain and show you how to do today is how to make a procedurally generated endless runner. The concept of this I hope to develop into something more fleshed out to where it will procedurally generate something along the lines of a Minecraft world. But right now it only works linearly, and I can only make it or use it to make an endless runner. So if you don't know what an endless runner is, great examples are Tomb Raider, Tomb Raider 2, Subway Surfer, not Tomb Raider, sorry, Temple Run and Temple Run 2. Subway Surfer, and there's a whole lot of other endless runners, pretty much where it's you just keep running and dodging obstacles and turning left and right. And obviously, most endless runners, except for something like Subway Surfer, I feel like most of them have you turning left or right or something. But this really, we're not programming the character of the endless runner, and I'm not planning on doing a series. If people enjoy this that much and want to know how to do an endless runner, I'll do some episodes on that, but right now I'm just showing you how to make the level generation or the terrain generation, where it's the same thing over and over again. Some things repeat, like you see the same rope swing, or you see the same train car that you walk by, or same pattern of stuff, or something similar, but it's not consecutive. It's random and it's procedurally generated. So that's what we're gonna make today. So you in Subway Surfer and in Temple Run, they all start off in the same thing. They also in Subway Surfer, it always starts off with him graffitiing the same train car and the same graffiti, unless it's a different map or world, because they change it up periodically where the location is. Temple Run, it's always him running out of a temple. So part of that, from my understanding, isn't just storyline based or main menu based. It's also to get the procedural generation going. It's an easy way to do it. That's at least what makes sense to me. So I just am in my blueprint folder, and I'm just gonna make a new folder here for endless underscore runner. I'm just gonna open that up. I didn't do underscore, I did dash, but it's whatever. And we're gonna want to create an actor blueprint. Now this is going to be an actor because obviously we don't need to possess it or anything. We don't need to control it. This is going to be our start of the procedurally generated world. And so I'm just gonna call this start underscore platform. And I thought I'd talk real quick while I'm doing this about how I came across this. Me and my friends were in school one day, and we saw someone playing a game on Y8. If you know what that stupid web browser site is, or browser game site is, then you know what I'm talking about. If not, it's just a site where you can play web games. Anyways, it was a really cool game where the idea is you make it it was an endless runner where you play as a ball and you make it as long as you can without hitting any of the red obstacles. And it was really fun. It became a challenge. It's still kind of a challenge. We still goof off with it. But me and my friends were like, hey, let's download Unreal Engine and try and make this better. And so I'm like, well, part of this is procedurally generated because the world is procedurally generated. Well, let's make this better. So I kind of tinkered around with it and I figured out how to make a procedurally generated world in about an hour or so, just in the middle of school. So, yay. Anyways, let's get into this by first, what I did is I just used a platform, and so I'm going to get a static mesh, um, and leave it called static mesh, and this is going to be, and if you downloaded the starter content or the starter content for Unreal Engine that comes with every project, it should just be floor, yes, right here, floor 400 by 400. Now what I'm going to do is I'm going to make sure your scale is locked. I'm going to scale this up by 2 so that way we have an 800 by 800 floor. You can make this as big as small as you want. Just make it easy to divide. So whether it's 1200 by 1200, because you could multiply this by 3, it would be 1200 by 1200. Just make it easy to divide by, because that's very important. If it's something like, oh, it's 1472 by 1472, that's not easy. I mean, it still is an even number, so it is divisible. It's just much easier if it's a rounded number in the hundreds or thousands. And the reason is because we need to center this, and we need to be able to also have an easy measurement. We need the measurement to be easy for another step. But let's center this by making the location -400, -400. So that didn't do that for some reason. Okay, -400. So that since if you don't scale it, the reason it's -400 by -400 to get it to the center is because it's an 800 by 800 platform, and the center, which is this little ball right here, that thing, that's the center, that was in the very edge of the corner. So we need to go 200 units in to the left and 200 in 200 units in and 200 units in deep to the left and to the forward, I suppose, whatever you want to call it. Anyways, we just had to go 200 units into the, in this case, 400 units to the X, 400 units to the Y to get it to the center. If you, excuse me, if you don't scale it up, if you don't scale it up and you leave it at the 400 by 400, it should be -200 X, -200 Y. Now, if you want it to be bigger, smaller, or a very, very specific size, just take that, take whatever you scale it to. So it's obviously defaulted at 400. Now, maybe you're not using this, and maybe you know that it's, 300 units, and you multiply it by 2. Now it's 600. Well, whatever you need to divide the measurement of one side by 2. So if it's a 12,000, you need to divide it by 2. That's 600. You need to do -600 by 600. That's assuming that it's a square. If it's a rectangle and it's it's 600 by 1200, then it should be -300 by -600, I believe, to get it centralized. Anyways, make sure it's centered and get all your measurements down properly. Excuse me. Still coughing, still a little sick. It's actually terrible. Anyways, so with that, we need to make it do its thing of spawning something. So how do we do that? We grab the tick, which should already be in your blueprint. If not, you should know how to do it by now, but if not, I'll still show you. Just right click and type tick and get the event tick. We're going to drag off of it and drag off the execution and get do once. Jeez, I can't spell. It's all one word. Do once is all one word, and we just need the first one not do once multiply or whatever. Multiple input. That's what that is. We don't need the do once multi-input. We just need the normal do once, and it should look something like this. It should look exactly like this, actually. And start closed should be false, and anything after this is going to only be ticked once. So, excuse me. So what we're going to do off of this is spawn actor from class. Now, this class, we will just for right now do start platform. But if we do this, what this is going to do is it's going to, if we place this in the world, it is going to immediately lag us out. Oh, well, let's, oh, right, I need to show how to do this. Drag off your transform and click on make transform, and here we need to make it seamless so that way they connect perfectly. Well, being that we know it's 800 by 800, we need the next one to be 800 units in the X, I believe. If I'm wrong, that's fixable, and you can just change it to the Y, but I'm pretty sure it is 800 units in the X. Anyways, that's all you're going to need there. If you have like a bigger platform, however long the length is, that's just what that needs to be. Not the division. It doesn't need to be 400. That's what I initially tried, but that kind of messed it up, and that put it in the middle. No, you actually want the whole length of what your platform is, or what you're standing on, or whatever, what your model is. Anyways, 800 is what I need to use. I just do always spawn ignore collisions just in case something is a little weird. You're just gonna want the procedural generation to keep going and going. So anyways, but like I was saying, what this does is if we place this tiny little blueprint, which this is not a lot of coding. I mean, this literally took, I mean, if I would have not talked over that and explained things, this would have taken me 30 seconds at the most. What happens is when we place this in the world, it's going to, since we don't have any kind of delay on it, and it just ticks, do once, and spawns itself again right in front of it. And since it's spawning itself, it's going to run this command, and then it's going to spawn another one, and it's going to run this command, and there's no delay, and it's ticking that. It is doing it practically instantly. It could generate miles upon miles upon miles of that platform in a split second. Honestly, I mean, it will murder your computer, and my TV just went out. There we go. I literally have to hit this TV just to make it turn back on, because that's fun. Anyways, so how do we prevent that? Well, that's a simple fact of I'm lagging UE4, and I'm afraid of crashing. Okay, anyways, never mind. Okay. So how do we prevent that? That is all that lagging and that instant generation. We put a slight delay on it. Now, I've tried to make the best delay possible, but make it what's possible for your computer while you're making it. And when you finalize the product, make it reasonable for the final product, not just what's being made in the computer. Because if your computer can't necessarily handle it, you know, whatever. But let's just get to how we solve that. Drag off of the tick execution before the do once, and just type delay, if I could spell. And it's under utilities, flow control, and delay. Now, by default, it's 0.02, and ironically, that's exactly what we want. I thought 0.02 was a little too quick, and so I tried 1, way too slow, and very visible. 0.5 was still slow and still very visible. 4 and 3, 4 was still slow and visible. 3 was much less so, and 2 seemed to be perfect. So if we play now, we just look up over at that. It's not going to do it, is it? Of course it's not. Nothing is ever going to work in my life. I realized what the problem was. The problem is I didn't tell it to go to a relative's location. So it's literally spawning a bunch of those at 800, 0, 0. So that's not what we want. So how do we fix that? Drag default root scene down. Actually, just drag down the static mesh. Get relative transform. Break the transform, connect the rotation and the scale. The location, we are going to break that vector. And on here, we're also going to break or make the vector. Connect the Z and the Y, and on the X, press plus, float plus float. Connect the top node to that, and I'm just going to do 800 there. Compile, play. Hold on. Let me actually do that so we can see also. Let's just connect this straight to there. I think that's good. I'll just still do 1 second, because why not? Everything else should be fine. Oh, it looks fine. I'm just gonna actually say self because this is driving me crazy. Relative transform. Okay, fine. We have to say default root scene is the issue then. There we go. Got it working. So now we've got that, but you know, say you want some variety in it. So let's make a create a child blueprint. I'm just going to call it ramp. Now open this up, and what we're going to do is take this, rotate it up, something like that, just say you wanted a ramp, because I needed a ramp for the ball game that we were doing. So just rotate it up however much you want, compile. But now, so what do you do? How do we get the flavor of inputting this in? Well, we have to make a couple things. We have to make first an enum, and I'm just gonna call this runner underscore enum, and then we need to make another blueprint that is a structure, and I'm just gonna call this runner underscore struct. Now under the structure we need to have two variables. One can just be called start, and the other can be called ramp. Obviously we're going to have them both be the start platform since they are both child, but we need class. So let's do start platform class, and then of course the first one will be the start, the second one will be the ramp, and you can do so on and so forth for however many different variations you want to make and be in your randomizer. Just make sure on the enum you do the same thing. You have start and ramp. I'm going to hit Control S just so we're good. And then over in the start platform, we need to get the struct. So I'm just going to make a new variable, call it struct, and we're going to get runner struct. Okay? And then we're going to drag it out, get it, and then off of it, I think we're going to break the runner struct, yes. Now off of this, we need to drag off of just one of them, type in select, and then select. The index, we're going to make it an enum, and just search for runner. If you named it the same thing as me, search for whatever you call your enum. I called mine runner enum. If you called yours something else, like, I don't know, flying enum or something, or just flying list, I don't know what you called it, just make sure that's what you search for. The index now is going to be whether you want it to be the start or the ramp. Leave it at start. That's fine for right now, but let's get start connected to start, ramp connected to ramp. Now this is going to be the selector, and you're like, well, if we leave it at start, then it's just gonna keep doing start, 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 start. And by the way, the return value needs to be connected to class over here. You're right, that is going to be start, start, and more start. But if I drag off and, oh, that's not going to work, never mind. Type random, and you'll have a couple random stuff in a couple options of variables for random. You'll have unit vector, rotator, integer, float, and bool. And they all have random bool from stream, random bool with height, random bool with weight, and then with weight from stream, and then with stream in range, and range from stream, and so on and so forth for its respective ones. Now, what we need is an integer in range. Now, this doesn't need to be connected to anything. This needs to be numbered, though, from minimum to maximum in a specific way. Now, mine's going to be from 0 to 1. And you're like, well, you've got two things you need from 0 to 2, right? My gosh, would my monitor quit doing that? It's actually a TV, to be honest, and an oldish one at that, but hey, it supports 1080, so I don't complain too much. Yay. That was a nice, TV banging. Okay, that was weird. Anyways, you're like, well, you've got two different things you need from 0 to 2. No, not really. That's because it doesn't operate like that. It doesn't operate in ways of from 0 to 2. Now, what it does operate in is in ways from, let's see, I need byte to that, and that to that. So what I just did there, if that was a little confusing, I dragged off of the index, I went to utilities, went to, enum, byte to enum, runner, enum, and then off of that, I just connected it to the random float range. But the way this works is the first one, which is start, is 0. Then the second one, which is ramp, is 1. So everything's counted from 0 to 1. So if you have 10, you need 0 to 9. If you have 20, you need 0 to 19. Now, if you want to make it easier on yourself, actually, no, never mind, that would not work, because then that one would never be included. Never mind what I was just about to say, because it's irrelevant and it would not work. Anyways, so the return value is going to be there, and since it's randomizing, it's going to randomize whichever one, and if it gets a number like 1.5 and smack dab in the middle, then I don't know how it determines that, but I'm assuming it just picks one, and I think it rounds up, so it's going to go to 1. But if it gets something, you know, like point 0.2, then it rounds down. It does its rounding method, and it works out fine. So let's compile that. Control S, and let's check it out. So we're going to get a random amount of, oh, that's right. Yeah. So it is fairly sequential, one right after another, but that's because, well, those are the only two things you have. You have literally two options. It's a 50-50 chance. And with 50-50 chances, the same thing is very likely to happen over and over again. As you can see, we've got a lot of platforms and a lot of that. But say, you know, you had much more options and you put those all in, because like in mine that we're doing on my computer at school, the one that I made, I have, I think, 5 or 6 different options, and it randomizes them between them very well. It doesn't seem like, you know, I don't get the same one over and over. It's varied up, but it is only 6, so I mean, it's not super varied. But if you had something where it was like, you know, 30 plus, if you spent the time to do that, or if you have something like that, if you have those objects, or, you know, if you're really into making this endless runner, which I'm not saying it's bad, because I love those endless runner games, I really do. But if you have like 30 plus, 40, 100 different ones, the chances of coming, you know, if you have 100 different ones, remember it's going to be 0 to 99 on that integer randomizer, but it's going to add so much more variety, obviously, because you have 100 different things to randomly pick from, that the chances of getting the same thing one after another are most literally 1 in 100. So I really hope this helped you with your awesome endless runner game that's going to be made. And if you are making an endless runner, I like to check it out, because I like those games. So yeah, if you could send that to me. Or maybe you're making an endless runner for PC, which people don't do that very often. I mean, I get why. It's easier on mobile, it's more convenient on mobile, blah, blah, blah. But still, you know, whatever. You could make a more highly graphic one, like an FPS endless runner, where, I don't know, whatever. Anyways, thank you so much for liking, commenting, and subscribing. If you did like the video, that like button tells me that you liked the video, and the more likes I get, the more I feel happy about the life I have in YouTube. But your comments are much more important as well. You guys' suggestions keep my channel going, and your guys' problems that you're having potentially with my episodes are keeping me busy and helping me improve my knowledge in Unreal Engine and helping me teach better, I feel like. Also, I've got a Patreon. If you want to donate to the Patreon, that's totally a thing. Link in the description. I got a PayPal. I think that's in the description. If not, you can go to my channel, and then the About tab on my channel's page. PayPal button is there. Yeah, you can donate that way if that's something that suits your fancy. So, anyways, that'll be all for this episode. Might have some sort of other episode going up soon. Oh wait, no, I won't. Never mind. Sorry. We'll see about another episode though coming up soon. But thank you so much for watching, and I will see you in the next one. See ya.